Now it's time to bring everything together. We're going to go ahead and implement our database servers with our application servers, and then we're going to go ahead and push this into production. Now it takes a few steps to get here, but I think we've laid the foundation really well to make this happen mostly easily. And then after you do this, it's just about continuously updating and upgrading the application we have. So I'm really excited to get started. How about you? Let's jump in. Configure our Python project to work with a SQL database. Of course, we already have those SQL databases set up, and we also have already installed SQL Alchemy. This is actually the package we're going to use to do that integration. And so to run this, first off, we're going to create the db.py module. This, of course, is going to be where we actually declare all of the things related to getting our database integrated with our Python project. So we'll go ahead and do from SQL Alchemy. We're going to import the create engine method. Now this engine is going to be, of course, the connection string to any SQL database. So we already had this connection string in our env file, right? Our .env file has this one in here, and we could certainly add it in as hard-coded as that. Now we spent a lot of time on environment variables, so of course we do not want to do that. Instead, what I want to do is go from config. We're going to import that get setting argument here, this right here. And so we can actually use my settings module in here. So get settings equals to get settings. And that should be with an S. Okay, so in this, we're going to do settings and then .appdb. And that should be this string right here. Again, in environment variable, so we can always verify that later if we needed to. Okay, so this creates the engine to actually connect my project, but we need to do a couple other things in order for it to actually connect. First off, we have to import the declarative base. So again, from SQL Alchemy.ext.declarative, we're going to import the declarative base, and we're going to go ahead and set that equal to base equals to declarative base. Okay, so we will use this in our models in just a little bit, but before we do, I'm also going to make another method called create db and tables, and this is going to be base.metadata.create all, and it's going to bind to that engine we have above. Okay, so this method itself we're going to use on our main.py. So I will come back to doing that, but the idea is we want to create all of the models that we end up making, and this is the function to actually do that. So the next thing is we need to actually set up a database session. So we have an engine here. This is just a way to connect to that database. But once we actually are running our application, we're going to want to make sure that we have a session with that database that can open and close depending on how we need it. So in other words, we just need to go ahead and do from SQL Alchemy.orm. We're going to import the method called session maker. And here what I'm going to do is right below base, I'll do session local, which is equal to session maker, and auto commit being false. Like we don't want to automatically commit everything. Auto flush being false as well. And then we're going to bind it to that engine. Okay, great. So this session local, what we want to do is actually use this in our views as well, or the actual, routes that we have set up with the functions associated to it. So we're going to make another method called getDB, and this method is going to do an instance of session local, and we're going to try to yield that instance. Otherwise, or finally, we will just do db.close. We'll actually close the connection to it. And Fast API actually handles this, I think, really well as far as getting the database instance and whatnot. Okay, so this is the baseline configuration that we need. Next, of course, we'll actually need a model. That model, of course, is also going to correspond to the schema or schemas that we've already created. So let's go ahead and take a look at that. inside of the schema module, we wrote two different classes that sort of model the data we're after. But really how it stands right now is we're really after 5 fields or columns for one single table. Now we're going to get a bunch of data related to this, but one of the things that is really nice about doing the schema modeling first, or writing out all of our schemas first, is to test and validate that data, because changing it on a Pydantic schema, this Python class, is really fast and easy, and we can still test what we're trying to extract from any given user, both in automated tests on tests_schema.py, but also we can add routes and test actual requests and stuff like that, things that we will do eventually, but just not yet. So the idea is to flush out the data that you're trying to model, or the data that you're trying to save in a database, flush that out first, then actually create a database model itself. So we're going to do the database model now, and it's going to be, of course, built off of that schema. So models.py, and I'm going to go ahead and copy everything that we had here to sort of work towards what it is that we're trying to build. So here's the different fields, right? So I do class entry, and I'm not going to give it a parent class just yet. We'll just go in like this, and we'll say ID, title, content, timestamp, updated, right? No big deal. Now I'm going to leave timestamp and updated out for just a moment, but now we need to actually build out whatever this is. Now, what are these data types? Well, this, as we said before, was an integer. This was a string, and it actually had a certain length to it. And this was a string and maybe had a certain length to it as well. But in our schema, we only did it on the title. Okay, so how do we actually declare those data types in an actual model using SQL Alchemy? Well, first off, we'll do from SQL Alchemy. We're going to import column, integer, and string. So column is the type of class we want to pass in here. We don't need the data type anymore. We could just say column. So each one of these is a column. No surprising there. The next, the ID itself, is going to be an integer. And this is a value that I want the database to set. One way to do this is by saying primary key equals to true, and also index equals to true, right? So this is going to be the primary key for this entry, and our PostgreSQL database should automatically auto-increment this each time. So it's going to add 1, 2, 3, and so on. Next is our title. Of course, this is of type string, and this data type from SQL Alchemy will help us enforce that. And we gave it a max length of 100. Now, we could always say 101 just to be safe, but 100 should be fine. Now, in this case, I'm going to go ahead and say index equals to false. The next one, of course, is also a string, and we don't actually need to initialize any max length at all. And again, index being false. Now, in the columns case, we actually want to pass in nullable being true. So that means that this content can be empty. This is just matching what we did with our schema. Perhaps you don't want that, but it is important to see that it can be nullable. Okay, so those are our 3 primary columns, but how do we actually turn this into a base model? Well, it actually goes back to our database itself, and that's this declarative base. We use this base class right here in our model. Now, granted, you could always initialize that same function inside of here as well, but I think it's best practice to actually go from DB. We're going to import base and just use that base class as our entry base. Now, I'm not quite done, and that is timestamp and updated. So what is it that I'm trying to do with these fields exactly? Well, timestamp is going to be a date time field. Updated is going to be a date time field. So I will actually bring those in and just go ahead and say date time here. And again, we'll go ahead and declare a column, and it's a date time field. And we can also pass in time zone being true. And I can do this twice. Same thing. Okay, so the timestamp though should only be set one time. The updated should be set every time this entry or this row, whatever this data is, every time it's updated, the updated field or column should actually update as well. So we can call something called onUpdate and set it equal to something. Now, your Python intuition might be to import date and time and use that module to set here. So like something like datetime.datetime.now. And overall, that's okay, but SQL Alchemy actually has a function to handle this specifically, especially when you update a lot of data at once. This won't necessarily update a lot of data at once. It would do it based off of some other data. So what we want to do here is we want to just come in and say from SQL Alchemy and then .sql import func. And what this will do is it'll allow me to actually set it based off of the database. So when it's actually updated, when this row is updated, not when a big bulky thing of it is updated. Now, of course, if you don't want to know about that, that's fine. You could totally still use date and time, but it's just not going to work as well as using func.now. The next one is server default. This is going to be func.now. So on the server side, what is going to be the default? And that's going to be just now. So in other words, these are automatically going to set on their own, where these other ones are not, which I think is definitely important to know. So the next thing is actually what the table name is for this. So we use 2 underscores of table name, and we're going to set this to entries. That's it. So the table name in our database will just be listed out as entries. So now that we have this, it's time to actually go back to our schema. This right here, what we want to do is update it so that it knows it should be using the ORM as well. So just adding an additional class in here and say class config, we're now going to pass in ORM mode being true. And ORM is related to the database itself. So that's what is going on here. We're actually creating a database entry. Our schema needs to understand that that's actually how it's going to be used, is based off of an actual database. Cool. So that is our model. Of course, now what we need to do is integrate this into our main.py as well as various views. All right, so now what we're going to do is implement views and actual API endpoints for just our schema. Nothing about the database just yet. Now, the point of this is to highlight and illustrate that the schemas are really good for validating data as well as serializing data that may be coming in. And it also gives us the foundation to then integrate the database pretty easily. And so we want to start out with a very simple one, which is very similar to this get method here of /abc. Instead of calling read ABC, we're going to, of course, call it entry list view. Because what I'm trying to do is I'm trying to return a list of items here, not a single dictionary, but a list of what would eventually be the entry model in the database, right? So that's the long-term goal here. So the endpoint itself could be entry or entries. It doesn't really matter what the endpoint is, but of course we want to return back some data here. So what I'm going to do is I'm going to jump into my test schema and grab the items that I already wrote out for this item here, or for testing list items here. So these are the items, and I'm just pretending like these are coming from the database at this point. Of course, they will soon, but for now, we just want to use the schema that we created for the list to serialize that data and have it come back correctly. And so I'm actually going to just return that data. So if we save it as is and then run uviacorn, let's activate our virtual environment. Actually, let's see where we are first. CD into the app, activate our virtual environment, and then uviacorn, and then main app -- reload. Okay, so let's go to that endpoint of entries and right here. Okay, so here's the data coming back, right? So it's overall pretty good data in the sense that it's just returning back these items, but it didn't serialize it in the way that I wanted, right? I want it to be serialized just like this entry list schema. So to do this, we're going to come back and import this. So from schema, import the entry list schema here. And now all I need to do to serialize this data is to change my response model to that entry list schema. But But of course, it's not one single item. It is multiple items. So again, from typing, we need to import list, just like what we did down here, right? Inside of our actual tests. So we'll go ahead and do it again and do from typing import list. Okay, so that gives us the data type of our list, and the response model, oh, and this should be response model is equal to that. Okay, so we save that and refresh in here. And what do you know? Now it's actually giving us that additional data. Now we had default data set up in our schema, which is why we're seeing that additional data in here. But the general idea is that we now have a way to serialize data as we see fit. So this is really just changing how it's being serialized, which we can use on all kinds of data. But since we have this method, let's go ahead and do the same concept with our eventual create method. And so what we could do is we could, of course, add a different endpoint here for a create method. But the nice thing about Fast API and actually a lot of Python web application frameworks is that you can actually handle different types of HTTP methods on the same URL. And we'll look at the different types in just a moment, but we're going to go ahead and do a post method here. And the response class is no longer going to be a list, but rather one single item. So going back into our test schema, if we actually go up to, let's say, for instance, this title here, actually, we don't have a good one overall, but I'll go ahead and just come in here and call it data. And let's give it a content of, ABC. Okay, and so entry create view, and then we return that data. And the list itself is, or the actual response model itself is going to be the entry create schema. And we'll bring this in here like that. Okay. And so now we need to test this actual API endpoint. Now, if you're not aware, APIs are really good for software to communicate to each other. Whereas like a actual template response, that's for us as humans to interact with software. API endpoints, one of the reasons to use Fast API is so that software can communicate with each other. So that means we need to run some software. And I'm just going to do some very, very basic things with this. And so we'll come in here and I'm going to go ahead and say test views.py. And in here, I actually want to create some very, very basic tests to actually make sure that our two endpoints are working as we expect. So what I'm going to do now is I'm going to open up a new terminal window, cd into our app, activate the virtual environment, and then pip install requests. So Python requests is required, so make sure that you also add it into requirements.txt. Now the reason it's required has to do with our test client itself. So we're going to go ahead and do from fastapi.testClient. We're going to import the test client class. Now you can actually think of this in terms of almost like requests, the actual Python requests. So like this. But it actually takes in the app, the actual Fast API app, as consideration. So we'll go ahead and do from main, we're going to import that app. Okay. And so now what we'll do is create a actual test client instance with our app in mind, just like that. And now what I want to do is I'm going to define, let's say, test the entries list. Okay. So our response is just going to be simply client.get, and it's going to be /entries, right? So literally this right here. Okay. And so what we can do is we can assert that response.status code is equal to 200. Now, this right here is also much like in Python request. It's something like request.get, right? So it's very similar to that, if not exactly identical, except it, takes into account our actual response itself. And so the next thing is also we can assert that let's say the length of response.json in this case is going to be equal to 2. And I know this should work out for now because in my view, I only have 2 items in this list. In the long run, it's probably not going to work out. But let's go ahead and run this test with, of course, PyTest, and then we're going to use test_views .py, hit enter, and we get this warning right here. This is related to the templating engine. I can sort of ignore that for now, but it gives me one passed. And when I say ignore it, I can totally just comment out the template view and run this again. And now it's all successful. I'm going to leave that template view in just for our own purposes later. But for now, that's good. We can see that this is actually serializing the data as expected. And realistically, I could also go through all of that data and ensure that it is coming just like the schema itself, right? So I could actually parse out this data and make sure it's equal to those items in that test, right? So in here, we could actually come in and here's these items. This is the actual object list, and we could verify that they are identical to this right here. But that's actually adding a lot of work to us that we're not going to use at the end of the day. Instead, I just want to make sure that it is parsing this data out and it's working correctly. In other words, the view itself, we're not testing the schema. We tested the schema outside of the view. Yes, you absolutely can and might most likely should test it in the view itself. But again, I'm not going to spend a lot of time on testing views. But now we're going to go ahead and actually test the create view. And so this time it's just going to go into create entries. And this one, the response JSON, the keys should be equal to the number of items or the number of fields in this one, right? So it's going to be most likely 2 keys here. So let's go back into our test views here. We've got 2 keys again, so the length of those keys. And let's give this a shot again. And we run through and we've got, not create, but rather post, and run that again. And this time we get 2 passed as well, which is great. However, perhaps I don't want the response model to be the create schema, but rather the entry schema, just like the list. Perhaps this is what I always want it to be, in which now if I run this, I get a validation error. It actually fails for me for several reasons. So one of the reasons is the actual data in here, right? So the data in here should have some sort of ID in order for it to validate. And then the other one will be the actual number of keys that come back based off of the schema that this is, right? So yeah, testing is valuable for many reasons, but this is just a simple way to do it. So now, before I go, let's go ahead and test one more aspect of this, and let's bring back this entry list schema here, entry create schema rather. So we'll come in and say entry create schema. And now what I want to do is pass in actual data here. So data into this schema itself, and I want it to be of that data type. And I'm just going to return back whatever that data is. So yet again, it should be the same schema data, but this time it's going to ingest that data. So going back into our views again, now I'll go ahead and say data equals to, let's just pass, or rather JSON equals to, let's pass in our data just as content and saying hello world. Okay, so we save that. And now let's go ahead and run it again. And what we get is a validation error. So it's not 200. So this is invalid data. If we change it to title and run it again, now it's valid data, or at least seemingly valid data for that specific endpoint. So let's create another one, test entries create and invalid. And this time we'll just do content, and we should see 422. And we run this again, and there we go. So now we're actually testing invalid data for that actual endpoint. And it's only related to the Pydantic model, the Pydantic schema that we already created. So now that we have all this, and hopefully it's well understood that what's happening here has nothing to do with the database. It's just validating the data or serializing it as a way to consume it. Now you can take these test views, everything that we did in here, and use Python requests to see how your actual code would interact with these things, and just change client to simply requests, right? All across the board. So that's another thing that I think is pretty cool about all this. So now let's go ahead and integrate the database itself. Now we've laid all of the foundation necessary to actually integrate the database into our REST API endpoint views, these right here. So to do this, the first step is we need to actually create the database and the necessary tables. So we need to trigger this function. And then we also need to use this getDB session. So the first thing is going to be this create DB and tables. So back into main.py, what we're going to do is import from DB, import that create DB and tables. The one thing that we could do is we could actually initialize it like this. That would work, and you often see it that way, where it's actually listed out as just the base.metadata.createAll command. And that works fine, but what's actually better, in my opinion, is to use app.onEvent and startup. So this decorator would go around any function, so you can call it on startup like I am, or you can call it whatever you'd like. But the idea is we have a unique name for this event of startup. And in here, of course, I can print out starting and save that. And then, go back into my project itself, you'll see that it says starting. And so this is actually where I want to call that command. And so it's going to take a minute to actually fully start up and have all of the endpoints and the views and all that stuff ready to go. But that also means that our database is ready to go, and it should actually find all of our models that inherit base.py. So entry is for sure in there. Now, what this does not cover at this point is actually migrating database tables. So if you made changes to this model now, like after actually creating the database and tables, you're going to probably run into errors. So be sure that you know what it is that you're going to want to have in models.py prior to actually creating the database and tables. Now, before I go down that rabbit hole any further, this is a development environment, right? So we have our dev Postgres server here. So one of the things you could do is you could totally create a brand new dev Postgres server, and it would be clean. It would have no data in it whatsoever. And then you would either change the IP address on Linode for that new one, or just update your environment variables to the new IP address in here. So that is one of the reasons I made it that way, is so it's really easy to swap out future dev database environments at any time. Also take down old ones and stuff too. But anyways, so with that out of the way, let's go ahead and now actually implement some things related to our database. The first one is by far the easiest, and that's this entry list view here. I'm going to go into the CRUD command, and we're going to go ahead and get entries here. So we're going to go back into main.py and import from the CRUD module. We're going to import get entries. And so if we look at the way that our view works, it literally just returns back a list. And so will SQL Alchemy if I run something like this. Now, in SQL Alchemy, in the actual creation of the CRUD, we see that we have a database session here. And then in our view, we do not have a database session at all. So what we can do is we can actually pass in a dependency to this view for that database session. So it takes a few imports here. The first one is going to be in FastAPI. We're going to pass in depends. And then this second one is exactly like what we did in CRUD for this session right here. So from SQL Alchemy, actually getting the session class. And then what we want to do after that is we want to bring both of these things into this argument here. So DB, the type is going to be session, and it's going to be equals to depends. And what exactly does it depend on? Well, in db.py, we have this method called getDB. It's going to depend on that method. So we just need to bring that one in as well. And so we come back down and we bring in this method. We do not initialize that method. It will handle it for us. And so now we can actually pass in the database as an argument to that getEntries function here. And so now the actual data itself is a little abstracted from the view altogether, right? So it's just going off of this right here, which I think is good and bad, right? So it's good in the sense that it simplifies how I handle all of my CRUD entries. It's bad in the sense that I have to remember to add additional functions to actually get to the point where I want with any given view, right? So some people might argue, oh, why can't I just do the get entries, all of the data right inside of this view, all of the logic there? So yeah, I think it has to do with making it just a little bit easier to diagnose later and more observable as to what's going on for all of the CRUD actions. and you might end up using that same method somewhere else. That's another reason. Okay, so now that we've got that, let's go ahead and take a look at our actual lists. Now, of course, it's empty, right? Hopefully no surprise there. I don't actually have any data to show for my project. So I need to actually create some data. And so this goes back into CRUD again. And this time we're going to be using that create entry method from CRUD. And down here, well, we can actually pass in create entry. But again, we need that database as a requirement. In the case of views, you put in the dependencies after you put in whatever you're posting in, like the actual data itself. And so this data is going to be second in how we did our create entry view. So in this case, for CRUD, I put the database stuff first and then have all of the other data later. And so in this case, we have two things that for sure will happen. The entry data, this actual data type, will match this data type right here. It has to. Same with the database. So that's another aspect of this, is you need to make sure that those are matching data types. And there we go. So we now have the CRUD endpoint here. So can we test this out with our original test views? Well, the answer, of course, is yes. What I'm going to do is I'm going to get rid of the response length. I no longer need that response. I now just need the response code, and that should help satisfy at least our current demands for tests. So PyTest and test views.py, hit enter, and we get, it's going to take a moment to actually run it. This warning is still happening again because of our templates and stuff, but everything else passes. And so now if I go into my entries on my running server, notice that I actually have data coming through, and it's only one item. So my tests did succeed. It has an invalid test still and a valid test. So every time I run this, it's going to add it into the database. This actual new entry is going to go into the database just like that, which I think is pretty cool. But if you're familiar with CRUD, if you're familiar with actually using APIs, the create view, any sort of API create view, really never responds back with a 200. It responds with a 201. And so this should say 201, and it's a really simple fix. We just go back into the endpoint and put in status code of 201. That's it. So you can absolutely change the status code in there just like that. And now we run it, and it's the correct status codes as well as the correct data that's coming through. And it's pretty cool that also my endpoint, the actual list view, is showing the data as needed. Now, in this case, it's also not doing updated, right? So updated is null. Now, the reason updated is null is because this data has literally never been updated. So there is a way that we could actually have it as the default, right? So we could have it run very similarly to the actual create, right? So the timestamp itself, right? So we've got the entry list schema. That's fine. That works okay. And then the actual model itself, we could also have that server default in here like this. Let's save it. Let's run this test. I did make a change to the models, but did it actually change anything about the column? And well, no. So it actually didn't even add the updated on any of these, right? So yeah, when you want to make changes, you want to have things happening. You want to make sure that you're doing it in advance. And what I just showed you probably won't even work in anyway, but the idea here is that when you need to change models, this is not the way to do it, to just jump in and change them. All right, so now let's go ahead and push our code into production. We'll do git status, git add -- all, git commit with the message of going into prod, and then git push all. Oops, let's make sure there's a space there. There we go. And so what's going to happen here is it's going to push your code, and there's going to be errors. So this error right here is likely what you'll end up seeing. Now, it's certainly possible that you have other dependencies that you already put in. This error is actually related to the fact that Python itself on our virtual machine has never really been updated to work with Postgres. So there's a few other things that I need to install, which means that I'm going to need to install those things and then reboot my other servers. So this is a little bit tedious, but definitely something that you will most likely come across when it comes to deploying things into production early on. And so in my case, I have one server that's working because I did some tests and the other two are not. So that's what we want to solve. We want to fix this bad gateway thing. And this bad gateway is actually not related to our load balancer, but rather to the actual individual services themselves. Okay, so let's go ahead and SSH into one of our servers here. And what I want to do is first off run the update, right? Just like that. And I can also run the sudo supervisor CTL of my app to see what's going on. And I could check the logs and all that. But I just wanted to make sure that, yeah, it actually is fatal. And so now I'm going to go ahead and do the necessary installations for Postgres. So feel free to pause this, but these are the things I certainly want to install and run. And so once I do that, I'm actually just going to restart my entire Git hook, which was that post receive hook, just like that. So run that bash command just like that, and it should actually install everything as needed. And so I want to get to a point where it's stable and it's actually working before I create a new image. So a new image that would include all these things. And now this actually shouldn't happen again in the future. It certainly could, but hopefully it doesn't. So we look at our status again, it's still fatal. And that's because I never actually restarted supervisor CTL. So restart our app itself. And it wasn't running. So now it's started. And so now I should actually have that new IP address in here working again. And sure enough, it is. So yet again, going back into Linode, going to the one I just fixed, I'm going to go ahead and create an image from this. So let's go into images. Let's remember that it's what the name of the image is. Images, create image, and web server US1 right there. Okay, so let's call this my production web server. And we'll call it 2, create image. And this other one, I'm going to go ahead and get rid of once my production web server has completed, which will take a little bit of time. And then after I do that, I need to actually provision some of these other ones again with the same IP address and do that transfer. But the main thing being that one of them is actually working. Now at this point, since one of them is working, I can power these off. Right? So turning them off will mean that at least my service itself is not going to attempt to go there. I mean, eventually it should know that those are down, and the actual load balancer itself should not even attempt to go to these web servers at all once they are actually down. And sure enough, it is looking like it's doing that in any moment now, which I think is great. I mean, honestly, yet another reason to use a load balancer. Now, this is also another reason to well test things out before you are officially in production, before you actually release things. And so that's why we have done so many tests. And that's also why in the setup process, we wanted to make sure that there was a load balancer. So if you did have any issues with any given server, you could actually handle that accordingly. So when it came to this big of a push, I typically would not push all of them. Instead, I would use one of the remotes, verify it's working, and then go from there. Because if I only used one of these remotes, then I could have just taken that one down really quickly and then brought up the other ones up to speed as needed instead of the challenge that I actually faced. And I mean, if you didn't know what you were doing, it might have taken you a while to actually recover from what just happened. But at this point, we now have that image created. So let's go ahead and create two more of these. I'm going to delete this old one. I should not need this anymore. Perhaps it's premature to delete it, but I shouldn't need it. And if I need to remake a new one, I still have the virtual machines available to remake a new one. And so back to production web server, shared CPU. The region is Fremont, and I'll leave it in as that. Did I call it we server or web server? That's funny. It says we. Okay. And that password, the same root password that I've been using, I will keep in here. And there we go. Create it up. And next thing we need to do is create another one. So in images, at least to have our fully 3 items there. Of course, this is, optional. You don't necessarily have to have another one, but I think it's a good idea to have at least 3 servers running in this case. Use that same password, SSH keys, and create. Okay. And so we come back, and the ones that are off, I'm going to go ahead and transfer the IP addresses. So into network, transfer, and move to, this is going to be, or we could do swap actually. So let's just do swap with, and production web west. And actually I need to verify the name again. So this is production we west and production web US west. Okay. And web server 001 is the one we don't want to change. Okay. So back in network, IP transfer. Okay. So there's the first one. You can close that out. And now I can actually delete this one. Should not need that Linode any longer. And then the second one. Okay, transferred successfully. Let's go ahead and delete this one. And then let's reboot these other 2. Okay. So a lot of this provisioning and actually setting up the server itself could be automated, or at least better used, making tools or with tools called Terraform and Ansible. We'd actually be able to do all of this with code instead of all of the console stuff that just takes a lot longer. But nevertheless, it's still important. And so the state of the code, once these things are up, the state of the code should be that it's exactly what all of the other ones are. So in other words, if I actually go into entries here, once those are up, entries should have an empty list, and we'll actually be able to do tests to this actual endpoint. I'm going to let it finish loading, and then we'll come back and take a look to make sure that all of these are up. All right, so they finished rebooting, so let's go ahead and take a look. And it looks like my load balancer is going to the 3 different IP addresses that I had set up before, which is great. Now I just want to go ahead and rename some of them so they actually fit with some sort of naming pattern. Granted, I could probably make them a little bit better and more attached to what I had before, but for now, I'll just leave it like that. That way I for sure have my production web servers going. Okay, great. So that's a really good start. And then now if I go into entries, I should be able to see that it is giving me an empty list, right? So it actually isn't creating any entries, but it is using an entry list. So now the last and final thing that we would need to do is actually test our production endpoint. And so this is going to be just a module I'll call prod calls.py, because I don't want this to be an automated test. I want to actually do it manually in this case. So the endpoint is going to be, well, this. And so in our test views, I can actually copy this a little bit and paste it in here. So now I'll go ahead and import requests. And in this case, I'll just give the client being requests. I no longer need the app itself. Instead, I can just run these things right here. So in theory, actually the endpoint should also be in each one of these, the actual API endpoint. So now I can actually just run each one of these functions as I see fit. So let's just go ahead and run the create function in this case. So I'll say if name equals to main, then we'll go ahead and run that test entries create. And I can also return back what the response is. So in this case, I'll just go ahead and print out response JSON. And so now that we've got that, let's go ahead and do Python prod and calls.py, hit enter, hello world. It looks like it is creating that content. Let's go back into our application, refresh it multiple times. We could always verify the IP addresses and stuff like that in this actual view. But as of now, all of that data is coming through exactly like it was locally. So we now actually have a production version in production running, and all of the code is ready to go, which I think is great. I mean, we hit a few roadblocks, of course, and that's inevitable to happen. And a lot of these things can be solved a little bit more rapidly with other kinds of tools. So certainly something like, these few tools, Terraform and Ansible, both of those, not necessarily at the same time, but sometimes in tandem, those will really help handle a lot of these issues. There's other ones like Chef and Puppet that also can handle some of the infrastructure things that we ran into. But as far as the code side, the actual application itself, it's now ready to be in production fully. Now, of course, you might be wondering about migrations. Those things I think are important, but it's a little bit too application specific. I just really wanted to get us to a point where the actual servers, the entire stack of servers, are working both in production and in development for this application. It wasn't about making the best possible fast API application, because the other bad part about this, the thing that's still lacking, is actual security on these API endpoints. Anybody can do this. It's not like there's authentication or anything like that. And that's certainly something that should be covered in another time. So if you do have questions on this, let me know. Otherwise, let's keep going.